Hi everyone. This video is going to talk about volume and surface area. In particular, we're going to focus on the following objects: the right prism, the pyramid, the cone, which is a type of pyramid, and the sphere. We're also going to look at combined objects, where we take various objects and put them together and work out their volume and surface area. Let's look at the volume and the surface area of right prisms. Before we get to the formula, let's look at how to define a right prism. Now, a right prism is an object that has repeated face, and the repeated face occurs parallel to the other repeat. So if you think about a rectangular prism, you actually have three sets of repeated faces. For this case, let's make my repeated face the top and the bottom. And we're going to call this repeated face the base. As you can see in the cylinder on the right, the repeated face will be a circle, top and bottom. There are no other repeated faces in a cylinder. Now, in a triangular prism, you'll see that the repeated face that runs parallel to itself will be a triangle. You might find that other faces are repeated, but those are not the base because they don't run parallel to each other. Now, let's see the volume. The volume for any right prism will be the area of a base times by the height. Now, if you look at the rectangular prism, the area of the base is length times breadth. So if I was to label the dimensions, that would be length, that would be breadth, and the third dimension will be the height of the right prism. If I look at the volume of a triangular prism, again, its area of base and the area of the triangle, because the triangle is the base, is half base times height, times by the height of the whole object. Now, if I look at the dimensions here, I could make that piece there the base. The height of the triangle is the perpendicular height of the triangle. And to differentiate between the height of the triangle and the height of the object, I'm going to use a capital H for the height of the object. For a cylinder, I know that the area of the base is a circle. So the formula for the area of a circle is pi r squared. And then the third dimension will be the height. So here you go. Here's the height of the cylinder and the radius of the circle that's repeated at the top and the bottom. Next, let's look at the surface area. Now, the surface area formula is going to be used depending on what you need. If you want the surface area just in general for any of these objects, it will be 2 of the area of the base, that will be the top and the bottom, or the left and right, plus the perimeter of the base times by the height. In grade 8 and 9, you probably did questions where you drew the net out, and so you'll know where this formula comes from. Now let's quickly see. For the surface area of a rectangular prism, if I make my base length by breadth, then my surface area will be 2 bases plus the perimeter of the base. I know the perimeter of a rectangular shape is 2 length plus 2 breadth times by height. The surface area of a triangular prism will be your 2 triangles, which is 2 of your bases, plus the perimeter of the triangle. Now, if the triangle is equilateral, you could just times one side by 3, but you don't know what kind of triangle we have in general, so it'll be the sum of the sides of the triangle times by the height. And lastly, if you've got a cylinder, the area of the cylinder will be 2 circles, so that'll be 2 pi r squared, plus the circumference of a circle, which is 2 pi r times height. Now, the thing about these formulas is they all work fine if you just have the object by itself. But what if you had a rectangular prism without a top? Or what if you had a triangular prism missing one of the triangles? Or if you had a cylinder without the top and the bottom and just the curved part? For questions like this, you need to think carefully about how you use the formula, and not just plug into the formula without thinking, but think carefully about which part of the formula you need to use. Next, we're going to look at pyramids and cones. Now, a pyramid is an object that has a base, and then it has an apex that is directly above the center of the base. Now, a pyramid could have various bases. So if you can see in my diagram here, I've got a pyramid with a rectangular base, or maybe possibly a square base, and I've got a pyramid with a pentagonal base. You could have any base on your pyramid. Now, the reason why I'm combining pyramids and cones is that a cone is pretty much like a pyramid, except it's got a circular base. The other thing you need to know about the volume of pyramids and cones is that they have a height, and you need to know what do we mean by height. So we've already defined the base, which I've got in yellow. Now the height is going to be from the center of the base to the apex. That's the height. So no matter what your object is, whatever kind of pyramid it is, your height is inside the object. So let's look at the volume formula for pyramids and cones. The formula is the same. It's a third area of base times height. So if I think about the volume of a pyramid, it depends on what the shape of the base is. So let's look at the area of the first pyramid. My base is a rectangle, so it'll be a third times the area of a rectangle, and the area of a rectangle is length times breadth. And then I'll times that by a height. Next, if I wanted to look at the pentagonal base pyramid, I'd have to work out the area of the pentagonal base and times it by the height. Or for a cone, if I want to work out the volume of a cone, it will be the area of the base, and the base is a circle, so it would be pi r squared, a third times pi r squared times height. Next, let's look at the surface area. Now, like I mentioned with prisms, you're going to have to think carefully about how you use your surface area formula. Does your pyramid or your cone have a base, or does it not? If it has a base, you'll need to add the area of the base on. If it doesn't add the base, you'll only do the area of the curved part. So let's see. For the first pyramid, I've got the surface area is the area of the base, length times breadth, plus the perimeter of the base times by the height. But careful, the height in this case is not the height in the middle. It is the slant height, and the slant height is the height of the edge of the shape. So if you don't know the slant height, what you can do is you can use Pythagoras to work out what the slant height is. Next, if I look at the cone, again, it depends on what I need. Do I need the area of the base? If I do, I'm going to say pi r squared. And then I'm going to add the curved part. So if I look at the formula, this here is the curved part. Again, I'm not going to use the inside height. I'm going to use the outside height, which is called the slant height. And I can use Pythagoras to work that out. Now, sometimes you'll see the formula for a surface area of a cone written in the factorized format. If you are using the factorized format, you must remember that that includes the area of the base and the area of the curved part. If you wanted to only have the curved part, you'd have to subtract the area of a circle from that. Finally, let's look at the surface area and the volume of a sphere. The best thing about the surface area and volume of a sphere is you just have to learn the formula for them. So the volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. So it's quite nice. All you really need for one of these is to know what the radius is. Now remember, with a hemisphere is half of a sphere. So if I want the volume for a hemisphere, I'm just going to halve the volume of a sphere. Now you don't need to learn the formula for a hemisphere as long as you understand what you're doing. Now the surface area is interesting because the surface area is going to have two parts. It's going to be the curved part and the area of a circle, which does not exist when you're working with a full sphere. However, Like with the other formulas, you need to think about the context about whether you're going to add that area of the base circle or whether you're just working out the area of the curved part. Now let's look at an example. The example says an ice cream cone model is made from a cone and a hemisphere. The diameter of the hemisphere is 1 meter and the height of the cone is 2 meters. Determine the volume and the surface area of the model. Let's start with the volume. Now before I get going, they've given me the diameter, but I need the radius. So the radius will be half of a meter. Let's work out the volume of the hemisphere. So the hemisphere's volume will be half of the volume of a sphere. That will be a half times by, and if I look up the formula for a volume of a sphere, it will be 4/3 pi r cubed. So now all I need to do is substitute in the value for the radius, which is a half, and either using my calculator or using mental maths, I can see that my volume should be 3/16 times pi. Now I don't normally round off here, I just keep it in terms of pi. Let's work out the volume of the cone. So the formula for the volume of the cone is 1/3 area of base, pi r squared, times by height. So I already know all those values. 1/3 times by pi r squared, which will be a half squared, and the height is the inside height, which will be 2. And so then I can work that out either on the calculator or in my head, and I get 1/6 pi. So my total volume, I just add my two volumes together for my hemisphere and my cone, 3/16 plus a 6. And if I wanted to leave that in a format with pi, it would be 17/48 pi, or to 2 decimal places, 1.11, and I need to put the unit, which is meters cubed. Next, let's work out the surface area of the model. Now the surface area is going to take a little bit more thought. Again, I know the radius is a half, and I know that 2 meters is the height. It is not the slant height, but it's the height. So let's start with the surface area of the hemisphere. Now the surface area of the hemisphere will be half of the area of a sphere. So the area of a sphere is 4 pi r squared, so I'm just going to halve that. So let's put my values in. A half times 4 pi, and then r is a half. And so that's going to give me a half pi. Next, I want to work out my surface area of the cone. Now I've got to think carefully. I'm not going to include the base because the base is covered by the hemisphere. So I'm only working with the curved part. Circumference times by slant height, 2 pi r times slant height. However, I don't know the slant height. I know what the big height is, that's 2. And I know that the radius will be a half. So now I can use Pythagoras to work out the slant height. Since the slant height is the hypotenuse, I'm going to add the other two and square them, square each of them. And then I'll work out what the slant height squared is. It'll give me 5/4, which means the slant height is square root of that, which gives me 5/√2, or root 5/2. Now I can actually go back and work out the volume of the surface area of the cone. So I know the radius was a half, and now I know the slant height is root 5/2. If I simplify that, I'm going to get root 5/2 pi. Finally, I can work out the total surface area. I'll add up the surface area of each part and then work out how much I get at the end on a calculator. I get 5,08 meters squared because it's an area. I find it's easier to keep my values as I go along in terms of pi or in surd form. That's the form with square roots in them. So that at the end, I have a very accurate answer and I only round off my answer right at the end, and I don't round off along the way and lose accuracy.